All right, so let's look at some of these examples. Some of these examples aren't too great to start off with, but we do get more interesting as we go through these examples. It says find the area of a standard normal distribution between a z-score of negative 1.44 and z equals 0. So what they're seeing is do you realize that we can use this chart on the previous page, but you're going to want that chart printed out. Trust me, you're going to use it endlessly. So can you use this chart if you have a negative z-score? And remember, the chart value is automatically the area between that z-score and the mean. So all they're saying is what's the chart value if you have a z-score of negative 1.44? So what you want to do is you want to go to the chart and you want to look at positive 1.44. So when your z-score is 1.44 on the chart, the area on the chart is 0.425. So if they want the area, they don't want the percentage, just give them this value right here. They want the chart value. So the answer would be 0.425. Let's continue on. Look at example 6. It says find the area of the standard normal distribution between z equals negative 0.67 and z equals 0. Again, all they're saying is what's the chart value when your z-score is negative 6.7? Well, if I have a z-score of negative 0.67, that's the same thing as a z-score of positive 0.67. There's no difference there. Okay, so I want you to look at the chart when your z-score is 0.67. If you have a z-score of 0.67, what is the area? And I see a value of 0.249. So what's the answer? 0.249. That's the area between the z value and z equals 0, which would be the mean, the area between it. Okay. Now it says find the area of the standard distribution to the right of 0.82. So here's what I want you to notice. If it says to the right of, this means above. And this value right here I want you to notice is positive. So if you go back to the previous page, page 8's video, in the discussion about page 8, it talks about how do we find the area above with a positive z-score. So if it's above with a positive z-score, just look at my notes. You're going to do 0.5 or 50%, 0.5 minus the chart value. If you want to know, and these are notes that I absolutely would have on my note card, if you want to know above with a given z-score that's positive, you're going to do 0.5 minus the chart value. So let's go ahead and look at that. Look at the chart. When you have a z-score of 0.82, what is the given area? So 0.82, when I look at that, I get 0.294. 0.294. Okay, 0.294 or 29.4%, either way. Okay, that is my area between the mean and that z-score. So if I want to find the number above that z-score, I'm going to do 0.5 minus that area, which was 0.294, which gives me a total of, let me do it real quick, 0.5 minus 0.294, I'm getting 0.206 would be the area, or 20.6%. All right, let's read this last one. It says, find the area of the standard normal distribution to the left of z equals negative 0.147. So we need to break this down and see what is our two things here. It says to the left of means below, and then our z-score here is negative. So I want you to look back on the notes on the previous page. What do you do if you want to find the amount below and your z-score is negative? Looking at the notes, it looks like I'm going to do 50% or 0.5 minus the chart value here as well. Okay, so if I want to know below and I have a negative z value, I do 0.5 minus the chart value. Again, it is not always 0.5 minus the chart value. That is just because we've been in those very specific conditions. So let's look at the chart value. If I have a z-score of negative 1.47, because it's symmetric, that's the exact same as a z-score of positive 1.47. So go ahead and look at the chart for a z-score of 1.47. I'm getting an area of 0.429. So what do I do then? What I'm going to do is because it's a negative z-score and I want to know below, I'm going to do 0.5 minus that chart value, which was 0.429. Go ahead and do that now. 0.5 minus 0.429. I'm getting a total of 0.071. 1 or 7.1%. I'll leave the answer as a decimal because they said area, and that's what this textbook tends to do, is leaves it in terms of a decimal. So 0.071 would be the area beneath the curve. Okay. So let's see what this says. It says the standard normal distribution areas, percentages, and probabilities. It says in the standard distribution, the area of the distribution x equals a to z equals b represents the percentage of the z values that lie between the interval from a to b, or the probability that z lies between a and b. So essentially all they're saying is if you have two z-scores and you find the area between those two z-scores, that if we use the chart, we're going to get a decimal. That would be the probability. And if you convert it to a percentage, that would then be the percentage that lie between them. So if I want to know what percentage lied between two scores, I'm going to use the two chart values, the A values, the areas, not the Z-scores. I'm using the A values, and I'm going to go ahead and subtract those two. But that's not necessarily what it is. You subtract them if they both are positive z-scores or if they both are negative z-scores. If they are opposite z-scores, you actually end up adding those chart values. I know that's a lot to think about, so I've written it all down for you on the next page.